The review for exam 1. I said that you don't need to worry about the first page on the review as far as having questions asked of that, like that on the test. The questions that you can expect to see on the test will look more like this. Remember, your first exam for the most part will be multiple choice on questions such as this, where you're asked to identify whether or not the value is a statistic or a parameter. It's real easy to make that a multiple choice question. On number 18, we're told a sample of 120 employees of a company is selected and the average age is found to be 37. Which will this be? A statistic or a parameter? This average age, is this going to be an X bar or a mu? It's a statistic. How do you know that it's a statistic? What there tells you? Sample. Alliteration helps you here. Samples go with statistics, populations go with parameters. Number 19, after taking the first exam, 15 of the students dropped the class. The class here would be our population. The proportion of students that dropped then would be 15 out of however many students were in the class. Would that be a statistic or a parameter? Parameter, because I'm looking at the population. There's nothing in this problem that indicates that I have a sample. You want to look for key words in these types of problems that will help you decide whether or not you're looking at a sample or a population. If I would have said something like all of the employees at the company were surveyed and blah 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 blah, whatever the results were, that would be a parameter because I looked at all of the company employees, not at a subset or a sample of the employees. Does that make sense? Look for key words here. I think most people understand that statistics go with samples and parameters go with populations. The challenge is to identify, based on the statement that you're given, whether or not you're looking at a sample or a population. Your test won't have these two, but this is the type of question you can expect to see. In the next set of questions, we're asked to determine whether the given value is from a discrete or a continuous data set. What does discrete mean again? It can be listed or enumerated. You have countably many of something. Continuous then is something that could be measured on a continuum, like a decimal value. Number 20 is the number of freshmen entering college in a certain year is 621. Is that 621 discrete or continuous? Discrete. I can't have a 3/4 of a freshman. The temperature of a cup of coffee is 67.3 degrees Fahrenheit. What is that? Continuous. It's measured on a continuum because you can break temperature down to however many decimal places you want, any level of specificity. The weight of Bill's backpack as he sets off on a backpacking trip is 48.3 pounds. Is the 48.3 pounds discrete or continuous? Continuous. The number of limbs on a 2-year-old oak tree is 21. That's discrete. What about shoe sizes? Shoe size is discrete. The length of the foot would be continuous. There's a whole bunch of different length of feet that will fit in one given size shoe. You can't use the fact that shoe sizes come in half sizes like a 6, 6.5, 7, 7.5 and just look at the decimal and say, oh, it's continuous. Not all decimals are continuous. Shoe sizes is one example that wouldn't be continuous, but yet still be a decimal. Ring sizes, hat sizes, things like that can be measured in halves, quarters, eighths, whatever, those would be discrete. Now, in this set of questions, we only went over nominal and ordinal, right? We never talked about interval or ratio. So on your answer key, anything that would be interval or ratio, you need to change the answer to ordinal on your answer key because we only talked about 2 levels of measure. Nominal, remember, is data that is a category only, a name only. Ordinal is numerical data or even non-numerical data that can be arranged in some sort of order. The temperatures of 8 different plastic spheres, would that be nominal or ordinal? Temperature is ordinal. The samples of spheres categorized from softest to hardest. That's still ordinal because there's order there. The salaries for college professors, ordinal, because you can arrange salaries in order from smallest to largest, right? Survey responses of good, better, or best. That would be ordinal because these are all degrees of goodness, right? If it would have been yes, no, and maybe, or yes, no, and undecided, then that would have been nominal. Do you see the difference? Temperatures of the ocean at various depths. Ordinal. Nationalities of survey respondents. That's nominal. On your test, I'll have to ask the questions or make the choices be only nominal or ordinal so that it corresponds with what you learned based on your book. Which means that if you're looking at the answer key for your answer here, your answer to number 24, 26, and 28 would be different because we didn't go into these other types of measure, the interval and the ratio, which makes it easier for you. But you lose a little something, but I was limited by what your book was willing to cover. The next set of questions says determine whether the given description corresponds to an observational study or an experiment. Remember, in an observational study, you don't change the subject in any way, shape, form, or fashion. You're just observing their behaviors or their thoughts or their actions. In an experiment, you provide some sort of a treatment to a subject to change it in some way. Number 30 says a marketing firm does a survey to find out how many people use a product. Of the 100 people contacted, 15 said they used the product. Would that be an observational study or an experiment? You're just contacting the people. You didn't change the people. And you didn't determine what they used or not. You just observed it. 31 says a clinic gives a drug to a group of 10 patients and a placebo to another group of 10 patients to find out if the drug has an effect on the patient's illness. Would this be an observational or experimental study? You were given a drug. That's an experiment. A sample of fish is taken from a lake to measure the effects of pollution from a nearby factory on the fish. This is an observational study because you didn't pollute the lake in order to observe the effects of pollution on the fish. That would have been unethical. The lake was already polluted. You then make your observation. If you would have intentionally polluted a lake to observe the effects, then it would have been an experiment. There's some things that we want to study that we can't make an experiment, like smoking's effect on pregnancy. We can't make pregnant women smoke if they don't already, so that could only be an observational study. Number 33. A political pollster reports that his candidate has a 10% lead in the polls with 10% undecided. What would that be? You're just doing a survey to figure out who's going to vote for whom. It's observational. 34. A quality control specialist compares the output from a machine with a new lubricant to the output of a machine with the old lubricant. It's an experiment because the machine is our subject and the treatment that we provided was a different lubricant. Does that make sense? We changed the lubricant, so this would be an experiment. Any questions about that one? I've had people get that wrong in the past, and so I think it could be confusing, but I don't see why. So if it's confusing to you, could you tell me why or help me understand what it is that I'm not seeing? No questions? Right. This could be observational, I guess, if you went to different places where they're already using the lubricant, but that's reading too much into the problem. This one's an experiment because there's nothing that says that you didn't change the lubricant. And lubricant is something that ethically we could change for a machine. Identify which of these types of sampling is used: random, stratified, systematic, cluster, or convenience. Everybody clear on what a random sample is? There's got to be some sort of element of randomness. What about stratified and cluster? Those two are similar. Do you remember the difference? Let me write down what the difference is because I think that'll be helpful. I think what gets confusing about these two is because you start out the exact same way for both of them. In the stratified, you divide the population into group. In cluster, you divide the population into group. That's the only point at which they're the same. Here's where they differ. In the stratified, you take some from all groups. In cluster, you take all from some groups. But you begin by dividing the population into groups for both of these. Systematic is pretty straightforward. It's like taking the first, third, fifth if you're doing every other one. Convenience is just what it sounds like. Is you're just trying to take the most convenient, easiest to access sample. So let's read through these then and discuss them. A market researcher selects 500 people from each of 10 cities. That would be stratified because we took some from each of the 10 cities. Does that make sense? We took some from all of the 10 cities that we selected. We divided our population into 10 cities, and then we took some, 500, from each of the 10 cities. 36. A tax auditor selects every 1,000th income tax return that's received. So the 1,000th one comes across the desk is selected, the 2,000th one, 3,000th, so forth and so on. What would this be? 37. A pollster uses a computer to generate 500 random numbers, then interviews the voters corresponding to those numbers. Random. 38. To avoid working late, a quality control analyst simply inspects the first 100 items procured in a day or produced in a day. That's convenience. Your key word there, to avoid working late. All right, let me change 35 into a cluster. So modified 35. A researcher wants to survey opinions of people in small towns. So in this situation, because he surveyed everybody in these two small towns, so small towns would be the population, that he's looking at, and he just takes a random sample of two small towns and then surveys everybody in the town. Because it's such a small town, you could do that. Does that make sense? So this would be cluster. Okay. It's because you had a sample up here from the cities, from each of the 10 cities. If you're surveying everybody within the group, then it would be cluster. Number 39 says the following frequency distribution analyzes the scores on a math test. Find the class boundaries of scores interval from 40 to 59. Did we go over class boundaries? I don't remember if we did or not. I don't think we did for this book. The class boundary is just the number that's halfway in between consecutive lower class limits and upper class limits. So here, from 40 to 59, the class boundary would be that distance or that gap there between the lower class limit and the upper class limit is 1. So I would take half of that. So that would be 40 minus a half, which is 39.5. And then 59 plus a half is 59.5. But I'm going to have to omit this from your test because I don't think we went over class boundaries, honestly. What I could ask you is what would be the lower class limit and the upper class limit. That would be fair game. So the first number that you see is called the lower class limit. The second number is the upper class limit. But we're going to omit this question from the review because I did not explain that before the test. Number 40 says the following frequency distribution analyzes the scores on the math test. Find the class midpoint. This is the one that I said your answer will be different from the review answer key because your book taught you how to do midpoints different from the book that I used to get this review. So from 40 to 59, the way that I taught you in this course to find the class midpoint is you would take the 40 plus the 60, the consecutive lower class limits, add them together, and then divide by 2, not 20. 40 plus 60 is 100, and 100 divided by 2 is 50. So your class midpoint here would be 50. This question is fair game on the test. It's just that your answer, I'm going to have to change it on the test so that it'll reflect the correct answer. Next problem, number 41, says the frequency distribution below summarizes employee years of service for Alpha Corporation. Determine the width of each of the classes. Do you remember how we find class width? The consecutive lower class limits, we'd look at the difference from consecutive lower class limits, or we could look at the difference between consecutive upper class limits. Either way, what is the class width going to be here? 5. Because 6 minus 1 is 5. 11 minus 6 is 5, 16 minus 11 is 5, so forth and so on. And I could do the same thing going back. 10 minus 5 is 5. All of these differences have to be the same if you're looking at consecutive lower class limits and upper class limits and the difference between those two. So the class width here would be 5. Number 42, we're told a nurse measured the blood pressure of each person who visited her clinic. Following is a relative frequency histogram for the systolic blood pressure readings for those people aged between 25 and 40. The blood pressure readings were given to the nearest whole number. Approximately what percentage of the people aged 25 to 40 had a systolic blood pressure reading between 110 and 139 inclusive? We look on this graph between 110 and 139, and that's going to be this range right here, from here to here. Does everybody see that? Because this is a relative frequency histogram, I can look at the height of each of these columns, and then that gives me the percentage of people within that range of values. So there's 0.35. For this one, we look over to the side and we get 0.25. And then for this one, we get 0.15. And if we were to add 0.35 to 0.25 and 0.15, that would be 75%. So this would be 0.75, or I think they said percentage. That would be 75%. Any questions about that one? You don't have to worry about that, whether or not to write your answer as a decimal or a percent. On a multiple choice test, I would give you the answers. They would all either be decimals or they'd all be percents. You just got to find the right one. But do you see how I determined what that relative frequency is? When they give us a range of values here, we look for them on the table and then see how many bars and which ones we have to add up the relative frequency for. Number 43. This would not be a multiple choice question. It's hard to draw a histogram if you make it multiple choice. The frequency table below shows the number of days off in a given year for 30 police detectives. So there's the days off and the frequency. Construct a histogram. Use the class midpoints for the horizontal scale. Does the result appear to be a normal distribution? Why or why not? What we would do here, so for the first one our frequency is 10. We need to go up to 10. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm using the class midpoints on the bottom here. So for the first class, it goes up 10. For the second class, we have a height of 1. For the next class, we have 7. For the next class, we have 7 again. So we have 2 columns with 7. And then another column with 1. And then the last one's going to go up to 4. Sorry, it's hard drawing straight lines on this slick screen with this pen. But that gives you some idea of what it would look like. We'd have a total of 1, 2, 3, 4, 5, 6 columns because we have a total of 6 classes. And then the height of each column would be 10, 1, 7, 7, 1, and 4. We good with that? This would not be a multiple choice question on your test. Number 44, we're told the graph below shows the number of car accidents occurring in one city in each of the years 2001 through 2006. The number of accidents dropped in 2003 after a new speed limit was imposed. How does the graph distort the data, and how would you design or redesign the graph to be less misleading? This distorts the data because we didn't start at 0. Whenever you don't start your vertical scale at 0, what it does is it exaggerates the differences. I left off a part of this question. We were also asked, does the result appear to be a normal distribution? Looking at our histogram, does that appear to be a normal distribution? No. Why not? It's not symmetric and bell-shaped. And this graph exaggerates the differences. Number 45, it says find the mean for the given sample data. Unless indicated otherwise, round your answer to one more decimal place than is present in the original data values. We're going to use our calculators to find the mean, so let's get our calculators out. Do you remember what we need to do first? Do you remember how we put our data into the list? Stat, and then enter. If you already have data in your list, you can clear it out just like I'm doing here. Highlight the name of the list and hit clear. Do not hit delete. Does it matter what order I put my numbers in, if I'm going down the columns and then across, or if I go across and then down the rows? It does not matter. It doesn't change anything. What does matter is that I type in the correct numbers. So once you get your data in your calculator, you do want to double check your data and make sure that you didn't make any typos. It's quick and easy to do that on your test. It's way easier than getting the problem wrong. Once you get your data into the calculator or into the list, what's your next step? We're going to go to the home screen, and how we do that is by hitting second mode. What do we do next? Stat, go over to calculate, and then press enter, because that'll give us our one variable statistics. This is one option for finding the mean. and we're going to use it right now. Stat, go over to calculate, and then press enter. I've got my data in list 1. I don't have a frequency table, so I leave that blank, and then I hit enter for calculate. My mean then would be right here. This would be 59.4. Is that the only way I could have found the mean on my calculator? No, another option would be to hit second stat, go over to math, and then mean is number 3, and then tell your calculator what list you want to use, and it gives us the same value. I like the one variable stats because it gives us a lot of information at once, but if you're only asked to find one thing, you may want to use that other option of hitting second, stat, go over to math, and then down to mean. But if you use this option, you've got to tell your calculator what list to use after it pops up mean on the home screen. And you can rewind the video to see me do that again if you need to. Number 46, the local Tupperware dealers earned these commissions last month. Here's their commissions. What was the mean commission earned? Round your answers to the nearest cent. In order to do this one, we start by putting our data into the list, and I'm not going to write these steps down again because they're already on the review in the previous problem. We're just going to use the same steps. Let's type in our numbers. Once you get your data in your calculator, you go back to the home screen, and we do this by hitting second mode. And since this is the last command that I have is to find the mean, I can get that command back on my calculator just by hitting second enter, and then move over and change my list 1 to list 2 by hitting second 2, and then it'll calculate the mean for me, and I get $30,094.01. 3094.01. Now that's the answer. They said round to the nearest cent, so that 0.013 is going to be rounded to 0.01. It may have looked funny because that 3 was there as your answer on the calculator, but when you look at the answer at the bottom of the review, it has this as the answer. If you got something different, the first thing I would do is double check my list of data, because if you change one of those numbers, it's going to throw your answer off. That's why I said it's really important that you double check your data. Number 47 then is to find the median for the given sample data. You could do the same thing and put your data in your calculator and do the one variable stats to get the median, but this list of numbers is small enough that we can sort our data and find this by hand, can't we? So we have 1, 2, 3, 4, 5, 6, 7, 8 numbers. We have to first arrange these numbers in order from smallest to largest. And then we find the halfway point. There's 1, 2, 3, 4, 5, 6, 7, 8 numbers. 8 divided by 2 is 4. That goes evenly. That means I have 4 numbers to the left and 4 numbers to the right. The way that I find the median then is I average these two numbers. The median will be equal to 22 plus 29 divided by 2. And that happens to be, so our median is equal to 25.5 years. 48 is to find the mode of the data set. What does mode mean again? Number that appears the most. What will my mode be? The mode here will be equal to 33 and 94. When I loaded this problem and copied it over, at first glance my eyes saw the 33 because the 94s were so far apart from each other, and if I wouldn't have taken the time to stop and look at it, I could have gotten it wrong easily. On your test, this is a very easy problem, and you guys know how to find modes. The danger is if you get in a hurry and overconfident because you say, oh, I know how to do this, you may miss one of the modes, assuming that there are 2 modes. So slow down and be careful on those problems. Number 49 says find the variance for the given data. Round your answers to one more decimal place than the original data. I am going to write down the steps for finding the variance. We do want to put our data into a list. Then we go to the home screen. For standard deviation, we could use the one variable stats, but for variance, we have to go into the math mode of the list. And how we get there is we hit second, stat, go over to math, and then down to variance. And I think it's number 8 that's the variance. And then we're going to put in the list that corresponds to the data. Fortunately, this is a short list of numbers, so we hit 5, 3, 16, 1, and 20. Once you get your data into the calculator, you hit second mode to go to the home screen. Then we're going to hit second, stat, go over to math, and variance is number 8. I just hit number 8, and then we've got to put the list that corresponds to where our data is, and I believe I put mine in list 3. So that means that the variance of this list of data, which we would use S squared as our sample variance, is equal to 71.5. In number 50, we're asked to find the standard deviation for the given sample data. Round your answers to one more decimal place than is present in the original list of data. We start by putting our data into the lists. And I'm going to move over and use list 4 and then go to the home screen. How do you want to find the standard deviation here? We have options. What do you prefer to see? The one variable stats or using the list? The one variable stats? Okay, we'll do that. So we hit stat, go over to calculate, and then hit enter. And my data is now in list 4, so I need to change that to list 4. We don't have a frequency distribution, so I leave that blank and then I hit calculate. This is the output that we get. Which one of those numbers there is the standard deviation that I want? There's two standard deviations listed here, right? There's the SX and the sigma X. Which one do I want for my answer? They're two very different answers. The S, because this is a sample of data. The sigma, remember, goes with the population, and the S goes with this sample. So our answer here is going to be S, our sample standard deviation, is equal to 65.07. Or they said round to one decimal place, so this would be 65.1. And the units here are dollars, so $65.10 would be the sample standard deviation. I don't remember if we went over the range rule of thumb for finding variances in this book, did we? It's pretty simple. The standard deviation is approximately equal to the range divided by 4, but if we didn't go over it, I'm not going to hold you accountable for it. So you can omit number 51. Number 52 says to use the empirical rule to solve the problem. 52. The systolic blood pressure of 18-year-old women is normally distributed with a mean of 120 and a standard deviation of 12. What percentage of 18-year-old women have a systolic blood pressure between 96 and 144? Here's how you would use the empirical rule for this. Remember, that's the one with the normal curve. And what number do we put in the middle? Well, it would be 0 if our mean was 0, but for this problem, what were we told the mean was? The mean is 120, so we're going to put 120 in the middle here. Then we add and subtract one standard deviation as we go out. Does that make sense? Our standard deviation here is 12. What's 120 minus 12? And what's 108 minus 12? And what's 96 minus 12? 84. Now we add going to the right. 120 plus 12 is, 132 plus 12 is, and 144 plus 12 is 156. So here's our mean right smack dab in the middle. And if we go out one standard deviation, what percentage of our data lies within one standard deviation? 68%. If we go out two standard deviations, what percentage of our data lies within two standard deviations of the mean? And if we go out three standard deviations, what percentage of our data lies within three standard deviations of the mean? Your book says almost all. It's 99.7. Looking at the problem now that I've got this graph drawn for the empirical rule, what would be my answer? Between 96 and 144, I'm looking at two standard deviations. This would be 95%. In your notes somewhere you need to write down empirical rule means this 68, 95, 99.7 distribution relationship between data. Is everybody okay with how I came up with these numbers here? The 120 is the mean, and that was given in the problem. The mean of 120. And then we were told the standard deviation is 12, so I added 12 as I went to the right, and I subtracted 12 as I went back to the left. When you draw this, don't worry about it being perfect. I just want it the right shape, symmetric and bell shape, and then go out a distance, you know, the same distance to the left and the right, and then write the right numbers down here at the bottom, and you'll be okay. Number 53, I may have to modify for you guys because I'm not sure if we talked about unusual values. Did we? I think we did, but I can't remember. Of course, if I give you enough information up here, you can figure it out. It says find the z-score corresponding to the given value and use the z-score to determine whether the value is unusual. Consider a score to be unusual. Here's where I tell you what unusual means. Consider a score to be unusual if its z-score is less than -2 or greater than 2. I thought we did do this. This is a fair game question. Do you remember the formula for finding a z-score? Data minus the mean divided by the standard deviation. I'm writing it out using words. So we need to figure out reading this problem what our data value is, what the mean is, and what the standard deviation is. Then we just drop it into the formula. A weight of 224 pounds among a population having a mean weight of 158 pounds and a standard deviation of 23.5 pounds. For this particular problem, what is our data value going to be? 224. And what is the mean? 158. And what is the standard deviation? When you put this in your calculator, you need to be careful. Let me show you what I'm talking about. If I just typed in 224 minus 158 divided by 23.5, I'm going to get the wrong answer. It's going to be way too big. Why is this wrong, or what do I do to make it right? You got to put parentheses around the numerator because I want to divide that difference by 23.5. Your calculator is only as smart as you are. If you know that that numerator needs to be divided, then you've got to insert parentheses around that difference. And now I get the right answer of 2.8. Is this an unusually heavy person at 224 pounds based on this mean and standard deviation for the population? This is unusually heavy because 2.8 is greater than 2. I'm going to take a teachable moment here just to review the concepts that we talked about when we went over z-scores. Remember the empirical rule that we just talked about? If I'm talking about z-scores, I told you this was a standard normal distribution. And we would have these numbers down here for the mean and the standard deviation. Do y'all remember that? If we go out 2 standard deviations from the mean, we said that was where our middle 95% of the data values lie. Notice that corresponds, that bulk of the data, the 95% corresponds to z-scores between -2 and 2. Anything beyond greater than 2 or less than -2 yields what we consider to be an unusual result. Unusually low if our z-score is down here, unusually high if our z-score is up here. 2.8 is almost 3, it's way up here, so that would be an unusually high number. Oops, thank you, -1. This would be unusually high. And then the last question definitely would not be multiple choice. Couldn't be, because I'm asking you to describe any similarities or differences between the two distributions that are represented by the box plots. Things that you want to address here are things like the shape, the center, and the spread. And to discuss, to help us distinguish which box plot I'm talking about, I'm just going to call this box plot A and box plot B. I'd recommend that if I give you 2 box plots to compare, you do the same thing. So before I start talking about similarities and differences, I want to talk about how to read the box plot when it's got a vertical alignment as opposed to a horizontal alignment. Think about the X and Y axis. Normally, your box plot is laying horizontally along the x-axis, and we have small numbers to the left and large numbers to the right, so forth and so on. Well, when it's got a vertical alignment, our small numbers are going to be at the bottom and our large numbers are going to be going up. Does that make sense? So down here, this would be the minimum value, and then we would have Q1 right here at our first line segment on the box. The median would be this middle bar inside the box. Q3 would be right here. And then our maximum values would be where the bar ends on this box plot. So talking about the shape of the two box plots, how do they appear to be, or do they appear to be normal or skewed? This one's going to be more skewed than this one. This one I could probably, by some stretch of the imagination, almost call normal because these whiskers here are similar length, and that's close to center but maybe not quite. So what I could say is A has a more normal shape, whereas B is definitely skewed right. How did I determine this was skewed right? Is that bugging anybody? Now I am going to draw my grid back. On this box plot, half of your data is going to be bunched up down here at this low end, right? And the top half of it is spread way out right here. That's going in a vertical direction. That means that most of my data is going to be down here at the low end, and then it spreads out at the high end where that long tail is. Does that make sense? It's easier to see if you change that vertical shape to a horizontal shape, because then you can tell the left and right. If you want a key to help you remember it, top goes with right, bottom goes with left. So their shapes are different. A appears to be more normal because it looks like these tails are about the same length here, and B appears to be more skewed right. The center is where the middle of the data is. So I would say the median of A is greater than the median of B. Does everybody see how I got greater than? Remember I said your smaller numbers are down here at the bottom. Well, the median's in a higher position on A than it is on B, so higher means greater. So the center of the data would be different. Now the spread. They do appear to have similar ranges because the minimum and the maximum values appear to be the same for both of those. And remember, the range is just the difference between the minimum and the maximum values. But if we look at the interquartile range, because that's a spread as well, we would say that the IQR, the interquartile range of A, is less than the interquartile range of B. The distance from here to here is my interquartile range, and the distance from here to here is my interquartile range for B. Do you see how the interquartile range for A is much shorter than the interquartile range for B? So even though they both have the same range overall, the middle 50% of the data in B takes up a lot more distance than the middle 50% of A. And that's one way that you could answer this question. What you need to keep in mind is these 3 points need to be addressed. And when I make out your test, I'll try to include these points in the instruction in the problem. But you're just pointing out similarities and differences between the shape, the center, and the spread for the two distributions that are represented by box plots. And that wraps up the review.